So we have now done how to add vectors. What we now have done is, when are two vectors equal? So we had Max over here, and we had Tori over there. Max moved 1 meter to her left. Tori moved 1 meter to her left. So we can say, if we want to do it a bit more mathematically, Max had, let's say, a displacement, let's just call it again R, which is equals to 1 meter to the left. Tori had exactly the same displacement. And when I gave Tori the instruction, I said, change your position by exactly the same amount. So do exactly the same as Max did. So if we want to write this mathematically, we can just say, if I call that R1, R2, I can say these two vectors are exactly the same. And the condition on that is, if two vectors have the same magnitude and the same direction, they are equal. Even if they're not at the same point in space, doesn't matter in which coordinate system we are working. Tori could have decided, thanks, sorry. And there's an I there as well. That's H. So if Tori decided, well, for me, X is going to be in that direction, and Max decided, for me, X is going to be in that direction, so they've got completely two different frames of reference. They both ended up 1 meter away from where they started, and from our perspective, in the same direction. So it's a funny thing about vectors is it doesn't matter in what frame of reference you work, they don't have to be originating at the same point. Two vectors are equal if they've got the same magnitude and they've got the same direction. So that's the only condition for two vectors to be equal. Right, so